So, ladies and gentlemen, good morning. I am Monica Bachchan, the founder of Metalogic Projects Management Services, and it is with great pleasure and excitement that I welcome you all to our webinar on bridge design and construction for safety and sustainability. Today marks a special occasion for us as we restart our webinar series after a break of 2 years. This is our 49th webinar, and we are thrilled to be back, more inspired, committed than ever before. Bridge are not just structures, they are symbol of connectivity, progress, and resilience. As we embark on this journey to explore bridge design and construction with a focus on safety and sustainability, I'm honored to introduce our esteemed panelists who are expert in their respective fields. Firstly, we have Professor Mahesh Tandon, Chairman of Tandon Consultancy, a renowned figure in bridge engineering whose expertise has guided countless projects to success. We also have honor to have Mr. Vivek Gupta, Director of Ductile Design Consultancy, whose expertise in structural design analysis has contributed to the success of completing of numerous bridge projects. Next, we have Mr. Ravindra Kumar Goyal, IRES Principal Executive Director Bridges from Indian Railway. His presentation on successful design of a railway bridge will offer invaluable insight into the intricacies of railway bridge design and construction. Joining us is SS Garawar, Chief Scientist and FMR, Head Bridge Engineering and Structures Division. From Central Road Research Institute, his lecture titled as Ensuring Safety Protocols in Bridge Through Structural Health Monitoring will delve into cutting-edge techniques for ensuring the safety and integrity of bridges. Lastly, we will also have Mr. Alok Bhaumik, Managing Director of BMS Engineering Consultants Private Limited, who will be shedding light on the critical topic of bridge failure, root causes, and ways to mitigate the risk of failure. His insight also mitigating risk will undoubtedly provide valuable lessons for all of us. To all our esteemed panelists, thank you for joining us today and sharing your expertise with our audience. I'd like to make a special mention of Mr. Abhay Gupta, Dr. Abhay Gupta, rather, from Skeleton Consultant for helping me out to find the gems of this industry. Thank you so much, Dr. Abhay Gupta. To our listeners, I extend a heartfelt welcome back to Metalogic PMS webinar series. Your continued support and participation means the world to us, and we are committed to delivering insightful and engaging content in the webinar to come. Without further ado, let us embark on this journey of exploration, learning, and collaboration as we dwell into the fascinating world of bridge design and construction for safety and sustainability. Thank you, and let's make the comeback webinar a memorable and enriching experience for all. Thank you so much. Now I welcome our first speaker, Professor Mahesh Tandon, Chairman of Tandon Consultancy, to start with his presentation. Over to you, Mahesh Tandon, sir. Requesting you to kindly open your webcam and open your presentation, sir.
Webcam है, mic है. We share.
विंडो 6 विंडो इसमें खुला हुआ है ना 4.5.
Good morning, everybody. Can you see my screen?
Yes, sir. We can see, sir.
Yes, sir. We can see your screen.
Okay, thank you very much. And obviously you can hear me. Otherwise, you would not have answered the question.
Yes.
So it gives me great pleasure to be a part of this webinar series that Monica has initiated again. So it tells you, the first slide tells you basically what I'm going to talk about. Some suspension bridges, past and present, cable stayed bridges of more recent origin, and of course, a couple of railway bridges, which I think are of great value as far as webinars like this are concerned, because these are really outstanding structures in many ways. Let me start with something which is pretty old. क्या हो गया भाई इसको?
So you are audible, sir.
Can you see the slide?
Yes, sir.
Oh gosh, okay, thank you. So this is called the Lakshman Jhula suspension bridge. It is in Rishikesh in Uttarakhand. It was opened in 1930 by the East India Company. The span is 137 meters and it's a very narrow bridge, 1.83 meters. It is a pedestrian bridge which was also used by motorbikes till recently. But in November 2020, it is closed. And now there are barriers on both sides of the bridge to prevent passage of motorcycles and scooters. It is really now become a cultural heritage as per the words of the Chief Minister of Uttarakhand. And I think this is done very timely because if you see the next bridge, this is the Morbi Bridge, as you must be knowing that this collapsed. It had it had already served its design life of about 100 years or more, and you can see this photograph is taken 24 hours before the collapse, because the bridge, which was under repairs, was opened only about 4 days prior to this, and when you have a lot of people who don't realize that the bridges you can't, particularly pedestrian bridges, you have to just cross the bridge and not play around with it. Here's another group of youngsters, which you can see. They are shaking the bridge. It is quite enjoyable for them, but it can prove to be a disaster, as it did in this case. This is a real live shot at the time of the collapse. So why did the Morbi Bridge collapse? Probable reasons: corrosion of the main cable, fatigue also of the same, overloading. As per the present capacity, whatever capacity existed was 100 kilogram per square meter, which is from today's standards is only about 1/4 or 1/5 of what bridges are designed for. But given all the problems that it had, it did not even 100 kilogram per square meter probably was too much. And of course, then there is the vandal loading, which I showed you how the bridge actually collapsed with the some youngsters trying to enjoy the swaying of the bridge. So that we call as the vandal loading. We cannot design bridges for that. It is difficult. The next bridge I want to show you is Ram Jhula Bridge, which is also in Rishikesh, Uttarakhand. And this was constructed in 1986. The design is similar to Lakshman Jhula, and it is located 2 kilometers upstream. The span is slightly larger, 230 meters, and the deck width is also larger, as 2 meters. The third bridge in Uttarakhand, Dobra Chanti suspension bridge, and this span is 440 meters, which is quite a big span, and it has got a width of 8.25 meters, which is again quite large, and it is a motorable single lane bridge. As you can see, at the moment there are no cars or motorcycles or anything. It's basically pedestrians, but you can have. It is designed for to be motorable also. So these are the three bridges I wanted to show you presently in Uttarakhand, and I think that when a bridge becomes close to its design life, it is better to close it down and treat it as a heritage structure rather than trying to extend its life and using it for other purposes. You can
Tandon
make
sir,
another.
sorry to interrupt. Can you put your slides on the slideshow mode? The screen is coming very small. Many people are requesting for that.
Sure. Let's see where it is.
सर नीचे है ना एक आइकन लाइक अ
वो नीचे तो आपका पिक्चर उसमें आ गया तो वो तो दिखाई नहीं दे रहा, पर ऊपर भी होता है।
हाँ सर ऊपर भी है।
ऊपर होता है न्यू स्लाइड
mode.
रीयूज।
Sir, press F5, sir. Press
sorry?
F5. Press
F5.
F5 button. Yes, sir. F5.
Let's see where F5 is here. We've never used F. This is
सर
F5. F5.
नहीं तो सर आप मेन्यू में स्लाइड शो देख लीजिए, उसमें ही टॉप पे है स्लाइड शो में। आप ऊपर
अभी?
चलेंगे। हाँ यस यस
Yes,
यस
sir.
इट्स ग्रेट इट्स ग्रेट।
Okay, so let's go forward.
यस सर थैंक यू।
This is all I want to show about the suspension bridges. Let's go to cable stayed bridges, which are, this is the recently completed Bed Dwarka Bridge. And you can see in the picture, in the inset, our Prime Minister waving out to the crowd, and this is on the opening day. It is rechristened as Sudarshan Setu. This is the longest bridge span that we have in India today. It is 500 meters in length and its width is 27.2 meters. So it's a 4-lane and bridge with 2.5 meter footpaths on either side. Because as you know that this is really one of the pilgrimage, part of the pilgrimage circuit, what we call Char Dham. This is one of them. And the contractor, SP Singla Constructions, he's one of the contractors who has made several long span bridges in the country. I wanted to talk about what the deck is. All these bridges which have been constructed, particularly in India, they have a composite deck. What does it mean? If you see on the right hand side top, there is a slide of the signature bridge in Delhi, which also had a similar deck. The picture below that, which is numbered 1, you can see that it is a grillage of beams as seen from the top, and you have a number of things poking out, as you can see from the grillage itself. And in this gaps that you have in between the grillage, you put a precast concrete plank, which you can see in picture number 2. The precast plank is being brought to site, and in number 3 you can see that it is covered, that gap between the grillage. And number 4, you can see that to make it all monolithic, this whole composite construction, we have a cast in situ construction which goes all along the top of the grillage, which you can see in number 4. The longest span is still under construction by the same company, and this is the 6-lane 700-meter span, which is called the Delhi-Katra Expressway, and it goes through Amritsar and so on. And this is also one of the expressways which is going to be a sort of a religious journey. And you have even Katra coming there, and you can visit Mata Ka Mandir. So this bridge is just, the construction has started. This is the old second Hooghly Bridge, which is got a 35-meter wide composite deck. This is where really cable-stayed bridges started in India, and it had Actually, when it started, it was a world record, but it took so long to construct that by the time it was completed, there were 3 more bridges which had already crossed that span of 457 meters. I want to talk about 2 great railway bridges of India recently completed. This is the asymmetrical cable stayed bridge, which has its biggest span of 290 meters, and the other span is 183 meters with, of course, a support in between. And the remarkable thing of this structure, apart from the fact that for a railway bridge, this is quite a big span, 290 meters, poor geological conditions and steep slopes, that did not prevent railways to do a wonderful job uh, in this bridge, and the contractor was Hindustan Construction Company. Last slide, which I want to show you, is the Chenab Bridge, which is, I am sure that you must have heard of. It is the world's tallest railway bridge, 360 meters tall up to the deck from the if you compare the compare it with the other tall structures which we know well, Qutub Minar, and you have the Leaning Tower of Pisa, and of course you have the Eiffel Tower. The Eiffel Tower, which is 324 meters, you can see that it is dwarfed by the bridge itself. So this is a remarkable achievement. And the way it was constructed was that it was cantilevered out and using all the time a stay cable temporarily, so that you can complete the arch. And after the arch was completed, in the last picture that you see on the right hand side at the bottom, the deck was incrementally launched or push launched from either end, and that is how the deck was made. I think this is again a remarkable structure, an achievement by the Indian Railways. The contractor was Afcons. Okay, thank you very much for your kind attention.
Thank you so much, sir. And next, we will have Mr. Vivek Gupta, Director of Ductile Design and Consultancy. Over to you, Mr. Vivek Gupta. Request to please share your slide.
Thank you, Monica. Am I audible?
Yes, you're audible, and your slides are also visible. Please put it on. Okay. Please share your slide. Meanwhile, audience, if you are unable to join through Teams, this program is currently online. It's going live on YouTube. You need to go to the app YouTube and find Metalogic PMS. You will find the program is going live there. And the recording will also be available post program. You will find the recording of the program on YouTube, Metalogic PMS channel. Thank you. Yeah, Vivekji, you can put it on slideshow mode, please.
Thank you, Monica. So it's a really honor for me to present a discussion on this platform, Metalogic. So any steel structures, and in the case of steel structures, we generally launch it by some great methods which are very common for all types of railway spans. So one by one, I'll discuss about different methods of launching or the railway spans.
Slideshow mode पे कर दीजिए विवेक जी एक बारी.
This is already on slideshow mode.
No, we can see all the slides.
Okay. Is it working now?
We still can see the entire screen. From the menu bar, you can select the slideshow. Because
Here I have selected slideshow.
No, but we are able to see the entire screen and
Okay. Let me try it.
yes. इतने important slides हैं ना आपके, nobody want to miss any part of it. So the audience is requesting especially. You have worked so hard on these slides. Please open your PPT, Vivekji.
Yes. Is it on slide mode now?
No, still not.
No.
आप bottom right में भी देखेंगे ना, there is a icon of slideshow.
Yes,
Otherwise,
I'm
from
using that only.
okay. I think then let's continue.
Yeah, it's
Otherwise,
better
we
to
will
continue.
lose out on time. Yeah, otherwise we will lose
Yes.
out on time.
So now I'm going to start a brief discussion on launching of railway spans. So first I'm going to start with what is launching of girders. So launching is basically placement of pre-assembled steel RCC PSC girders at desired location using different methodology to complete the task of making bridge. So there are two things. First one is launching and second one is erection of superstructure at the site only. So here we will more discuss about launching schemes in which we launch the entire truss or bowstring girder which is pre-assembled. And one example I'll take about which will be erected at site only. So this is most basic example of launching. So mostly simple launchings we are doing by using cranes. This is telescopic crane. We are using two cranes here and we are lifting PSC girder and placing it on the two piers. So this is the basic definition of launching. Now coming to this point, why launching is challenging. So launching is one of the challenging tasks and it is being taken very seriously everywhere. And what are the reason, what are the things that makes it challenging that I'm going to discuss here. First one is being temporary arrangement. I'm going to highlight this word temporary arrangement. So we have seen many civil engineering construction. Most of the civil engineering structures are permanent in nature. And we have faced many casual approach in the permanent structure. So now we can imagine what are the problems we are facing if we claim any structure as a temporary structure. So launching is a temporary work. So people take it very lightly. So that's why there are so many failures in the launching. So this temporary word making it very vulnerable. So when we say this launching scheme is temporary, it means after launching, we will remove all the arrangements from here. So that's why people are not taking all connections, all arrangements very seriously. At the place of 5 bolts, 6 bolts, they are tightening only 2 bolts. So this is the approach. So this makes it very vulnerable. Second one is site constraints are different. Launching depends upon site and type of structure we are going to launch. So site is always different. Every site has some unique specifications. So corresponding to that condition, we design each and every launching. So this makes launching very challenging. At some places, crane movement is not possible. At some places, a space for assembly of girder is not available. At some places, working radius is not available for the cranes. So these are the site constraints, and we have to keep all these things in mind. Second one is time constraints. First,
So sorry,
in
sir.
general,
Sorry to interrupt. Sorry to interrupt. I think slides hasn't been changed, I think, because we are able to see slide number 3 only.
okay, so now it's working properly.
If you could just try and change the slide, because we are able to see slide number 3. Am I right? As in everybody can tell me what
Yes.
slide number they are able to see.
Yes, I'm explaining third number slide only.
Okay, sure.
Yeah.
All right.
So time constraint. So time constraint. So during launching, there will be at sites where some vehicle movement from the vehicle movement below the bridge is going on, or train movement is going on. So in that case, during launching, you will have to block the traffic. So during that block period, you have to launch. So this time constraint is very important. Next one is reutilization of material. In general, launching is a temporary work, so that's why material which is used at one location, that is again reutilized at some other locations also. So that's why reutilization we always keep in mind while designing any launching. Less coordination between designer and site officials. At the time of finalization of launching scheme and execution of launching, this there is a time gap between these two activities. So that's why there is lack of coordination between designer and site official, and lack of skilled manpower. Launching is very specific work, and because of that, very skilled manpower is required, but we don't get that much skilled power at every launching site. So these are the things that create problem and challenges in the case of launching. Different types of launching we are using, especially I am talking about railways span. So crane launching, that is one of the most simple launching. I will explain these things through photographs also. Crane launching with launcher beam. What is the use of launcher beam? That I'll explain. Longitudinal sliding with cantilever nose, side slewing, and incremental launching. So these are the standard launching methods. One by one, I'll explain. This one is most simple launching method, that is crane launching method. Here we use simple one crane, and this crane lift one girder and place it over the pier. So what are the key points that we keep in the mind during preparation of launching? First one is crane capacity. Crane capacity should be sufficient to ensure the proper safety. Then placement of crane. Placement of crane will decide what is the radius of working of crane boom, and what is the boom height. So placement of crane is very important. This will decide the radius and height of the boom. Then capacity of sling. Here this is sling. This sling failure is very common because people are very casual about the sling. If sling will fail, the entire girder will come down. So that's why sling capacity is very, very important. We should keep sufficient margin while designing any sling. And nowadays, people are writing clearly what should be the dia and material property of the sling in the launching scheme drawing to avoid this type of failure. Then lifting point from where you have to lift the girder, because if you lift the girder from here, then this portion will behave as a cantilever. Then this beam will be subjected to hogging bending moment, but actually this is designed for the sagging bending moment between two piers. So you will have to check both the things for the sagging bending moment and the hogging bending moments. Then inclination.
Sorry to interrupt. Are we still on the third slide?
No, I am on the fourth slide.
Because it hasn't been changed.
Crane launching is not visible.
नो नो नो, एक बार आप ट्राई करिए उसको क्लिक करके दोबारा से.
Okay.
Yes, now it is visible.
Now it is visible.
Yes, yes.
I think I should keep this in this type of mode only, not full screen. Then it will work well. Now inclination of sling. So this sling.
I'm sorry. This is slide number 6. What we are able to see, crane launching.
Yes.
So एक बारी आप अगर run through कर दें slide number 4 and 5, and then you move on to the 6 because we haven't seen slide number 4 and 5.
This
That's a
is
different
4
type.
number.
Okay. Yeah.
4 number is visible.
Yes. So challenges you have already discussed. This is the slide. Let's move on to the slide number 5, please.
This one is slide number 5.
Different type of launching. So this you have already touched upon.
Yes.
And let's move on to the next slide.
Yes, crane launching. So in this one is inclination of sling. We generally keep this sling angle. This angle is 60 degree or more. If angle is 60 degree or more, then horizontal force from the sling to the girder is minimum. So, and that will be the one of the best way of working by using cranes. So this is the way how we design crane launching. Second one is crane launching with launching beam. So here this beam is introduced. Now, what is the purpose of this beam? This beam provides this angle 90 degree. So in some cases, inclination affects this girder. So that's why to make it 90 degree, we provide a launching beam, and launching beam is connected to this inclined sling. So launching beam is designed. So in this case, some key points are same as crane launching, and only one thing is new here, that is design of a spread beam. Here this spread beam is designed for the bending moment as well as axial force. So that much is more than sufficient for this launching beam. Now third one is longitudinal sliding. Bowstring girder is widely used in the railways, and launching of this is one of the major thing, and this is very important at every site, because at every site there will be site constraint as well as train movement. So these are the few important key points that we keep in the mind while designing any longitudinal sliding. Longitudinal sliding, it means we are moving in this direction. So whether longitudinal sliding is by pulling or pushing method, it means we are pulling from here or we are pushing from here. So both methods are being used. Second one is roller and PTFE. PTFE is the material which has very low friction value. So we can slide it over the roller or on the PTFE. It is as per the site executive requirement कि वो लोग जैसा expect करते हैं, we design accordingly. Then supporting trussel. In this, these supporting trussels are designed. All these supporting trussels are designed. So distance of these supporting trussels are very important, because we have to keep proper clear dimension from the railway track, and correspondingly load is transferred on this trussel, and this trussel should be properly designed to avoid any failure. Then supporting girder. This entire bowstring is sliding over one girder which is placed over supporting arrangement. So this girder is also designed. Now last point is winch capacity and its location. Sometimes winch is placed over the pier, sometimes it is placed over the ground, and suitable pulley arrangement is made to pull it from one end. So winch capacity, what should be the capacity and what should be the location and connecting arrangement. So these things are properly defined in the launching scheme. Then longitudinal sliding with nose. This is one of the project which we have covered. This is in the Panipat, and here this is the bowstring, and this entire portion is the launching nose. So launching nose we use at that place where it is not possible to provide supports from the bottom. Here this is over the canal, and this span is 72 meter. So for 72 meter there is no support. So that's why we have designed cantilever nose, and by using this cantilever nose we are pulling it to the one end. And key points in this longitudinal sliding with nose is these points are common. Now these are the different points. First one is design of nose. In this case, this entire nose is designed. When we pull it from one end, then this cantilever nose is in cantilever condition. But once the free end of cantilever reach to the another end, then it behaves like a simply supported. So that's why we have to design it for the both condition. First one is cantilever and second one is simply supported. Then deflection of free end of the nose is very critical, because when entire portion is cantilever, then deflection at this end will be maximum, and that is very critical point which we check. Then a strength check of main girder. When entire portion is in cantilever condition, then there will be a huge force in the main girder like bowstring girder or open web girder, and for that we have to check the entire bowstring also, and sometimes a strengthening is also required in the main girder. In this case we did a strengthening also. Toppling check or counterweight. When this cantilever portion is in hanging condition, then another end of the main girder will try to lift, and for that we need to design sufficient counterweight to make it stable. Supporting arrangement for highest reaction. When maximum cantilever portion is achieved during erection, then you will get maximum vertical reaction here, and for this vertical reaction this support should be properly designed. This one is one of the good methods, side slewing. When the railway track is very high askew to the railway bridge, then in that case there are two methods. First one is either we design launching nose, but launching nose will be very costly because complete steel work will be involved. So it's better to go for side slewing also. Here we have assembled entire girder on this side and then we slided it in this way. So this is called side slewing method. This is also one of the good method which is being used at many places, especially where railway track is very askew to the road alignment. This one is cantilever incremental launching, which we did for the Mizoram project. Here, one by one members are being attached, and this entire truss is under formation through cantilever action, and this blue truss is working as a anchor span or counterweight. So one by one we are adding members and we are making it long, and finally it will reach in this way. It will reach to the support in this way, and this portion behave as an anchor span and counterweight, and these are the link members between these two truss. This link member we properly designed by using analysis. So here crane capacity, this crane which we run over the truss, so its capacity and its weight is very important while designing. Anchor span and counterweight is very important. Link member design is very important, which is here. Free end deflection. So this free end deflection is very, very important, because after connecting all members, the deflection should not very high. Otherwise, this will not be supported on the pier. Then analysis of girder for incremental erection. This girder is basically designed for the simply supported condition, but we are launching it by making cantilever. So that's why cantilever analysis is also required in this case. Now, last one, this is not as such launching, this is on-site erection, and this is going to be executed on Krishna River, connecting one bridge, Telangana to Karnataka. So this is one of the most important bridge of that area, 83-meter span of this. And the unique part of this bridge is this two portion is made up of steel, but all these members are cables. So this bowstring is made of steel members and cables. So erection of this is being designed by us, and it is going to be executed very soon. This is not launching, this is completely erection work, because assembly will be done at the site only. Now conclusion is, so this launching is really very important and very vulnerable thing. So that's why this needs more awareness. And in launching, wind load is very, very important, because launching takes some time. And during that, wind may come. So wind is very important. If we lose consideration of wind while designing or analysis, then that may be chance of failure. Launching scheme should be more detailed so that site people can understand entire launching scheme properly and work accordingly. Regular supervision of launching experts is required, who can ensure all launching scheme key parameters to be ensured at site. Then designer should visit launching site without fail. This is very, very important. Temporary does not mean less safety requirement. This is one of the most important point I want to highlight. Temporary structure doesn't mean that less safety requirement, because most of the failure are in temporary structures. Ensuring complete connection in supporting arrangements. I told you initially that at the place of 5 bolts, 6 bolt, people are using only 2 bolts. So these are the one of the major common reason of failure of launchings. And ensuring firm ground before launching, because settlement of entire system is very common in the case of launching. People don't go for firm ground, and sometimes there is settlement. So these are the points about launching. Thank you. So now I'm completing this presentation. So Monica. Hello.
Yes. Yes.
So Monica, over to you.
Thank you so much, Vivek ji, for your wonderful presentation. I will quickly move on to our next presenter. We have Shri Ravindra Kumar Goyal, IRES, Principal Executive Director Bridges from Indian Railway. Over to you, sir. Request you to kindly share your presentation. And Vivek ji, you need to stop share. Yes. Please share your screen.
Am I audible, Monica ji?
Yes, sir. Very much. You are audible.
Okay. I'm just sharing my presentation.
Right, sir. So after Ravindra ji, we will have Mr. S.S. Gaharwar.
Is my presentation visible?
Yes, sir. Your presentation is visible. Requesting you to please put it on slideshow mode.
Is it okay now?
So, we can see all the slides. You need to put it on slideshow mode.
I have already done it, I think.
No, sir.
What is the way out?
सर आप ऊपर देखिए मेन्यू बार में स्लाइड शो लिखा हुआ है होम के बाद इंसर्ट डिजाइन एनिमेशन स्लाइड शो
Design animation slideshow, yes. And,
you need to click on the slide show and from the beginning, yes.
Is it okay now?
सर from the beginning पे क्लिक करिए.
From the beginning, yes. Is it okay now? No.
सर क्लिक करिए एक बार, आया नहीं है.
Is it visible now in the presentation? Is it okay now? No.
The presentation आ रहा है but not in the slideshow mode, sir. So ये from the beginning icon है ना आपका first, you need to click on that.
That I have tried, but it is not working, I think. Probably Vivek was also facing the same problem. It is on my computer, it is on full screen.
It is full screen on your system. Okay.
So I think we have to move one by one
Okay.
In this mode only.
Okay.
So
Okay, let's
can I
start.
start now?
Yes, yes, please start.
Yes. So my topic is sustainable bridge. Actually, Indian Railways is the oldest transportation network, 1853. Since then, we are working continuously, and we are adding also to our network. And in the last 2 years, continuously, we have added 5,000 kilometers on our network in the shape of multi-type tracking works on new lines, gauge conversions. So we have got definitely the bridges also, they are increasing. So we have issues because we have not only to construct the bridges, we have also to maintain these bridges, we have to sustain these bridges, and all these things we have to take into account when we are planning the bridges, designing the bridges, and constructing the bridges. And as Professor Tandon has said that once the design life is over, you should not use those bridges. You should rather put them in a heritage gallery and then not to run the traffic. But probably we cannot do that. We have to many times run the traffic on the same bridges by doing health monitoring, and many times we have to continue to run even after doing the instrumentation. We have the case of Pamban Bridge. Recently, we continued it to the last stage. Although this bridge was initially constructed for meter gauge, but we used it for the broad gauge. And years together, we ran broad gauge traffic over that bridge. And finally, now a new bridge is coming up. So with this introduction, I'm just starting my presentation. Indian Railways, not only Indian Railways, in even highway sectors, there is a emphasis on growth. We have to increase the speeds. We have to expand the networks, and this is the focus of the government. So we have to think about the bridges, how to deal with them, particularly the old bridges, existing bridges. They have to be made sustainable, but how? That is a real challenge. So what is a sustainable bridge? A bridge which can be sustained even if its design life is completed, with or without strengthening or retrofitting for the intended loads and speeds. So this is a real challenge. So bridges, they need to be assessed for higher speed axle loads to ensure safety and serviceability. And they are largely old, as I've already told you. They have to be rebuilt or upgraded during gauge conversion. Many bridges we had retained during the gauge conversion, and we are running the broad gauge traffic over those bridges. So it is really a very challenging task to maintain those old bridges which are already running on the older bridges meant for meter gauge. So large part of it are over 100 years old, more than 25%. They are setting loads and speed far higher than the design loads. So effective inspection, maintenance, and management, that is the key. We have to do periodical inspection and effective inspection and do whatever is required to be done in those bridges as per the need. So this involves many activities: condition assessment, safety assessment, testing, monitoring, strengthening, and rebuilding, etc. My slides are moving. I think there is no issue in that.
Yes, I think you are on the slide which says bridges, types of configuration,
Yes,
and material.
yes. So the challenges are that we have got many different types of bridges. They are constructed in different types of materials. They have got different types of spans, different types of material, different types of spans, and all these things together, they are very diversified type of a stock that you are having. So open web girders, there are through type or understruct type. There are many more types in open web girders also. So anybody who is maintaining these bridges, he has to have a complete design understanding of these kinds of spans. Unless until he has this design knowledge, he won't be able to do it justice in maintaining these bridges, because he has to give the input at the required place. That will be the very effective way of maintaining those bridges. So I have just narrated how many types of bridges are there. There may be many more of type of bridges. So new developments are coming, as we have recently seen bowstring arches. It's a new ROB in steel. We have got cable steel bridges. Professor Tandon has already given a presentation about the cable state bridge in Anjikhat, and the steel arch bridges. Again, Professor Tandon has given Chenab bridge example. So these bridges are coming; they are posing the new challenges to us. Next slide, I think, is why old bridges are to be sustained. This is the reason, because rebuilding of large bridges is too costly, and there are large number of such bridges. We cannot do that just. So we have to have some studies so that we can sustain these bridges. That requires a lot of technical input into this. And rebuilding of span bridges, they are large in small, they are large numbers. Although they are small, we can do rebuilding, but that requires traffic disruption. When we have to rebuild a minor bridge, we have to impose a speed restriction, and then we need traffic drop to replace these bridges. And since the numbers are so large, the requirements of ETA, that is engineering traffic time, traffic allowance, and the number of blocks required, that becomes very large. So it is better to sustain the existing bridges to the extent it is possible. So what are the challenges? We have to identify the new areas of studies and research, training of engineers, and developing institutions which are having skilled manpower. Because this is another area we need to have skilled manpower who can do this job in a safe and satisfactory manner. So we also need to increase allocation of R&D and create domain expertise in the railway itself, first of all, and then outside the railway also. Then policy of new bridges for making them sustainable at the design stage itself. So it is very important when we make a new bridge, we have to see how it has to be constructed and then how it has to be maintained. And in case life extension is required, how it has to be done. And then finally, if rebuilding is required to be done, then how the rebuilding will be done. So what are the experiences of other countries that I will just share? Sustainable bridges is also the name of a project which the European countries undertook in the first decade of this century, that is 2004 to 2007. They did this project. They had the similar kinds of problems. And they wanted to, they visualized the scenario of 2020 and wanted to make the existing bridges fit for higher speeds and higher axle loads. So that was the brief detail. 32 partners, 12 countries, different countries. Gross budget was about 10 million euro, that is 100 crores at that time. Then it was started in 2003 and completed in 2007. Reports were given in 2008. So I will just briefly give you the objectives of the project. That was the prime objective: increase the transport capacity of the existing bridges by allowing higher axle loads up to 33 tons and higher speeds of 350 kmph for passenger trains. And residual service lives to be extended by about 25%. So for that, the enhance, to meet this objective, they have to they thought about how to enhance the management, strengthening, and repair systems. So just a minute. This is the stakeholders organizations. They were the academicians, they were the administrators, the research universities, consultants, and all kinds of organizations which can contribute to the project. They were taken into the planning. So this was a holistic job done. They divided the whole work into different packages, right from startup and classification, then guidance and review, loads, capacity and resistances, condition assessment, inspection, monitoring, repair and strengthening, then demonstrating field testing of all bridges and demonstrations on monitoring of new bridges, then finally training and dissemination of knowledge, which is the most important part. The proportions of the bridges were more or less like that we are having in our country. And again, they had more than 35% of the bridges which were older than 100 years. So top priority research areas were identified. Repairs and waterproofing of concrete, better testing method for existing bridges, serviceability of arches. The number of deliveries are more than 120. And then 4 of them deliveries were transferred into guidelines. And these guidelines were the most important project results for the end users. So this was one of the guidelines. Then the important things that they have found during that project is that they found that whosoever is inspecting the bridge, he has to be competent, he has to be trained. Like if you see in Sweden, Germany, these countries, they said education of the bridge inspector. They specify that the special inspection is to be done by a person who is structural engineer and or NDT expert. Similarly, in Germany, structural engineer plus certificate required plus a specialist support by inspectors. So this part is very important. Here also, in United Kingdom, trade examiner meeting the requirements of RTC, they had some specification and the examiner has to meet those requirements. Certificate required, qualification as bridge inspector required, professional knowledge is required. So at every stage, you need to be, you need to deploy a person who is competent to do that kind of inspection. So an integrated management system was proposed to be developed, which included documentation, inspection, maintenance, knowledge-based databases, and scientific approach for defect description, reliability, deterioration modeling. The proposed inspection procedure, which was suggested by the Sustainable Bridge Project, was that we should have 3-4 types of inspections. One is surveillance inspection, which is to be done continuously. Whosoever is passing over the bridge, he must see it, and anything objectionable, if he found, then he should be informed. Then routine inspection every year at the level of inspector. Principal inspection 3 years at the level of inspector plus a structural engineer who has to be associated. And what he has to see, visual plus simple tests if needed to guarantee the bridge safety level, that is fatigue, discover, etc. Then general inspection after every 6 years, structural engineer plus a specialist in case of doubts, and visual inspections in touching distance, within the touching distance. One should feel what kind of a feeling he is having, if the traffic is passing, the kind of vibrations he is feeling, all those things. Then specialized laboratories, if required, in special during the special investigations. Then monitoring, specialized laboratories, again there is a requirement. Then digital implementation of inspection results into the CA. CA is the condition assessment. So you can have the field reports, and then they should be available in a digital mode so that easily they can be accessed in case of need. So this is proposed inspection procedure which was suggested. Experts' opinion. In some countries, regular experts' opinion every 6 years, alternating with principal inspection, is mandatory as part of the main inspection. Only engineers with a minimum of 5 years of experience in bridge engineering, bridge design, or bridge rating are allowed to present experts' opinion. This is the area where we are lacking in our country. We don't have experienced people in bridge engineering because bridge engineering is not being taught as a subject anywhere. Bridge design, people are available, but then consultants mostly. They are over busy with their own works and they cannot devote enough time as required. And similarly, bridge rating, people are not aware about the bridge rating procedures outside the railways. Even in railways, very few people are actually aware about the bridge rating procedures. So further, in Germany, the experts need a welding certificate. Authorities control the education and training level of the experts. Experts' opinions can be planned in phases adapted to a phase-wise performed reassessment. So ultimately, the objective is, the final takeaway point is that the training and certification is necessary for the experts if they are to be deployed on bridge certifications. This is the procedure that they have suggested, how to do the inspection in a sustainable manner, in a systematic manner, so that the bridge can be sustained. In the initial stage, if you have got doubt, only refer to the design drawings and the loads, and based on that, take a decision. If there are doubts, then you go for detailed reassessment in phases. Phase 1, phase 2, phase 3, and last phase is decision-making phase, where you may require to take a decision whether to continue the bridge with some instrumentation or to downgrade it or to rebuild it. This is again the same phase-wise procedure. This is the type of defects in steel bridges that they suggested they should be categorized. Now I will show you some defects catalogs. This is on arch bridges, masonry arch bridges. This is on bearings, Again, steel bridges, type of defects, fatigue defects, some more defects in arches. In RCC. So now this is the rating system summary of condition assessment procedures. They give, they inspect the different parts of the bridge and they give a overall rating number. Based on that rating number, they take a decision that what kind of a repair regime is required for that bridge. So now I will show you technical research with project sustainability. This is okay. Yeah, this is a very important slide. Defects in railway bridges may be caused during the design because calculation errors or insufficient knowledge and standardization. So this is the area where the consultants needs to be concerned. When they design, they must think of that this bridge is to be maintained for a sufficiently long period of time, say 100 years, and even after 100 years, it needs to be sustained also. It may be sustained also. So if they leave any deficiency during the design stage, it will definitely going to reduce the service life. Why insufficient workmanship? So the workmanship, when we construct a bridge as per the design, the workmanship has to be of highest order so that no defect initially left can multiply, can manifest. And due to deterioration caused by the adverse environmental conditions such as exposure to chlorides, carbonation, alkali silica reaction, and freeze-thaw cycles. So that all these things should be kept in mind by the designer when he is designing a bridge. And then
Ravind sir, sorry to interrupt. Ravind sir, can I request you to continue the PPT after one presentation as Mr. S.S. Garwar has to leave at 12:45. So if you can, allow Mr. Garwar to make a presentation and then you continue, I will give you chance again from this slide number.
I can finish if you say in 2 minutes, very quickly.
Okay, okay, sir.
So these are the guidelines developed by sustainable bridges. Then advantages, and this is by the Euro project. The high level of objectives were set to make the existing bridges fit for 350 kmph and 33 axle loads. Now I will just immediately come to the Indian Railway System of Inspection. We have got a similar type of inspection system. Foundation is all these parts are being seen by our assistant engineer during the annual inspection. This is the frequency, superstructure, routine inspection 1 year, detailed inspection once in 5 years, and detailed inspection of the bearings once in 3 years. A special third-party inspection as per the need through some outside agencies like IITs, NITs, etc. This is the classification system. ORN number we give based on inspections. ORN number 1, if assigned, that means it is immediate attention is to be given, very rare case. ORN 2, within 1 year attention is to be given. ORN 3 is in a planned manner. That is a routine job that we take care so that the bridge is always in a good position. Then extensive monitoring till rebuilding is required and complete record is to be maintained. So these are the third-party audits that we undertake on bridges where we have got some doubts. Mostly ROBs we have been giving on third-party audit. Then
Goyal, requesting you to please pause for a while because he has to leave, so he will have to make a presentation, sir.
Okay, I will pause here, and from here I will move forward.
Yes, sir. Yes, sir. We will give you the chance again. So now I request you to please stop share, and Mr. Garwar, if you please open your presentation.
I've already done it.
Mr. Garwar, am I audible to you?
Yeah, you are audible, but
please open your presentation.
My screen is visible.
No, you need to share the screen, sir. You need to share the
menu. Yeah. Huh? How do I share this? Share.
So on the Teams.
Yeah. Yes, you are there, but
Sir, on the Teams, you will see the sharing option on the top.
No, I have gone for this share option, but I am not able to see my.
Your PPT is open, right, on the system?
Yeah, yeah. Now is it okay?
Yes, 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 yes.
It is in the presentation mode.
Yes, yes, yes. Please
Yeah.
continue.
So, good afternoon, everybody. This is the topic of my talk. And this is the sustainability of the infrastructure development. In the morning, we have been talking about a lot of opportunities of infrastructure developments, and linked are the associated benefits as shown in the slides. Now, the challenges, sustainability, the technical definition given in the slide, and you can say mainly, if we qualitatively, we can say um, highlight this: lower carbon and environmental footprints, protect natural ecosystem, prove resilient to the changing climates, and optimize the use of natural ecosystem after their infrastructure services. So these are the things, and definitely linked are the, you can say, number of developments also in terms of optimum innovative design based on limit state, then the modern construction practices and the use of the innovative materials. So that is the new upcoming trend, but it also gives the limitations also. What are the limitations? The construction practices still means a 50% share manpower and the machinery. Then the unskilled manpower, that's a problem. And the quality assurance, both during the construction stage as well as the O&M period. What are the effective solutions through technology intervention, use of modern non-destructive testing during the quality assurance construction period? And second one is the instrumentation of health monitoring. And that is the present, we can say, topic for my discussion. So this is the outline of that. Is starting with the maintenance cycle. This is a typical maintenance cycle touching the threshold. And of course, in between, rehabilitations are given, then it can extend the life cycle. Similarly, when it goes to the replacement, this is the rehabilitation, you can say, cycle, and this is the upgradation cycle. And health monitoring, this is the, you can say, very much a similar analogy as implied to the, you can say, human body. And this is the development, of course, 2020, that UK doctors, they have come up with the development of a sensors which can detect the heart attack much ahead, as shown in the slide. And this is precisely the analogy of the human body with the structure. And that is how we can say foundation, feet, ear, leg, and so on and so forth, as shown in the slides. So this is the need of the performance monitoring, validation of the design assumptions, since new type of innovative structures they are coming, and the requirement of assessing their health at various stages, pre-alarming warning signs regarding the safety of the structures, and the allocation of rehabilitation resources, and definitely the efficacy of the rehabilitation scheme, especially when it goes to the external pre-stressing, then the health monitoring plays a vital role. Now, starting with what to look for and what is the health monitoring. So basically, it is the symptoms, you can say the performance factors, performance parameters as applied analogy to the human body: strain, deflections, stress, tilt, vibration, temperature, crack, corrosion of reinforcement. Now, basically, the analogy says that these are the performance parameters. Once we have identified it, then you have to put the sensors right from the construction stage and keep on monitoring, keeping in view the lifespan of the structures. So there are various technologies as shown in there. There are electrical resistance-based sensors, electrical strain gauges like that. Vibrating wire sensors are there, fiber optic sensors are there, and recent is the piezoelectric sensors. So this is the, you can say, one slide showing the data acquisition system of the electrical sensors. And this is the vibrating wire strain gauge, works on the vibrating wire principles. And this is the installation showing during the construction stage in between the reinforcement, that vibrating wire strain gauges. Of course, the rosette is there, and the leads of those vibrating wire strain gauges coming out and getting connected to a data acquisition system, which is ultimately leading to the connection to a master computer and master computer through wireless, or if it is inside the box cell of a bridge, then through wired technology, just transmits the data to the various data collection centers. This is another, you can say, vibrating wire temperature sensors installed in the, you can say, in between the reinforcement before the construction. And this is the inside view of a, you can say, box girder, the N3 precision level that is there, having, you can say, very sensitive least count, just for measuring the deflection of the profile. And this is the earth pressure, you can say, vibrating wire earth pressure sensors. And this is the vibrating wire earth pressure sensor shown in the, you can say, embedded with the reinforcement. This is another sensor, tilt meter, works on with the help of this accelerometer principle. This is another inclinometer sensors, which is used just to see the inclination. And this is the working principle of that, especially very much useful while the sinking of well is concerned. This is the sensor, and this is how it moves. This is the vibrating wire surface mounted sensors, where the opportunity of the, you can say, installing in the pre-construction stage, that is gone. Even the post-construction or construction structures, we can install that. And this is the surface mounted mechanical sensors. Just performance parameter in this case is the strain. These are the accelerometer measuring the vibrations. You can say basically measuring the accelerometer and getting converted to the velocity, and using FFT analyzer, getting their, you can say, response converted into the natural frequency, mode shapes, and other parameters. These are the load cells used for measuring the earth pressure, or you can the processing force. So when it applies to the health monitoring or the instrumentation, then naturally the algorithm starts with the selection criteria of the sensors, suitability of the embedment in concrete. I showed 4 types of technologies. Electrical sensors, they are ready to use and throw type. For example, electrical strain gauges, particularly when you are conducting a load test on a, you can say, bridge, and repetition is not required, then those sensors, they are applicable. And when it is a long-term monitoring, that you are keeping your objective to monitor 25 years, 50 years, then the vibrating wire sensor technology, that is maybe relatively old, but it is very, you can say, promising, since the transmission of the data, there is no, you can say, much distortion of the data. Regarding the optical fiber sensors, yes, they are very much, you can say, advanced, and they are very much in use, but only thing is that they are less robust as compared to the vibrating wire sensors. And regarding the piezoelectric sensors, the response is in terms of enormous data, that interpretation, that is a challenge. So still, despite of a relatively somewhat old technology, that vibrating wire temperatures, vibrating wire technology and sensors working on these principles, they are still in use. These are the performance parameter. Now let us see a typical instrumentation scheme, how we design the instrumentation scheme. Everything is linked with the, you can say, the finance. The instrumentation, sometimes it was considered as a, you can say, cosmetic item. Now, slowly but surely, as the people, they are realizing the importance of that, they are just making it as an integral part of the whole construction and maintenance process. So this is just one example to have a feeling what is the instrumentation and how the instrumentation scheme is designed. This is a well foundation showing the various dimensions. Now, we have to keep the, you can say, cost of the instrumentation optimum so that it can be adopted widely. And so we need not to instrument each and every sections. We have to be selective depending upon the criticality of the locations and the performance parameter. So this is one typical example. Performance parameters, lateral earth pressure cell, and longitudinal and hoop strain. These are the performance parameters identified. And these are the locations. This is, you can say, the plan we are seeing. These are the location of the sensors. Now, again, and this is, you can say, the sensors location here, sensors location here. And this is as far as the superstructure is concerned. You see the center of the span, and you can say proximity to the piers considered to be having significant bending moment effects, torsional effects. So they are selected. This is one typical instrumentation scheme of instruments embedded in the superstructure. You see number of sensors, but this is optimum number, how we select. These are the details, temperature sensors, corrosion probes, as well as the strain gauges. Another view of the superstructure. Now, monitoring stages, at what stage the monitoring should be continued. Suppose we get the opportunity during, you can say before the concreting, so we have to install the sensors with the reinforcement of the structure so that after concreting, it becomes an integral part of the structure. Now, these are the various important monitoring stage. When I say the how to link with the safety of the structure, needless to mention that nowadays, seeing the trend that innovative design, they are also coming. And sometimes you can the supporting system in terms of, you can say the girders, launching girders, this and that, etc. They need to be, you can say, cautiously moved. And we don't know what is the cautious, what is the threshold of that. In that case, if the sensors, they are embedded inside the concrete section, and then the response of these sensors, they are received and compared with the theoretical results, one can put the control over the, you can say, the minus effect, whether it is going constructively, positively, or some you can say alarming stages there. So these are the various monitoring stages. And this is the rich experience of CRI. We have installed the instrument and we have successfully monitored the various bridges as shown over here. Of course, the majority are highway bridges, but needless to mention that we have monitored a number of railway bridges also. Once the sensors, they are installed inside the body of the, you can say, structure, this is the typical response. You see the number of sensors, they are systematically numbered, and these are the responses continuously getting recorded in the master computer. So this is there, and this is the profile of the, you can say, deflection profile of a simply supported girder. And these are the sensors details, and this is, you can say, the typical deflection limits, and this is the span. So we can get, this is the pre-stressing of the cable pairs. It's all there. So different stages, we can have the response of the span. This is a simply supported span getting hogged up during pre-stressing. This is another, you can say, view results of the, you can say, sensors, and you can say value of the performance parameter continuously being monitored. This is the temperature response. You can say temperature sensors in this, you can single cell box girder span. You can say superstructure. These are the sensor position, and this is the readings. The differential temperature profile, and it reminds me the, you say, era before 2000 where IRC were not having a, you can say, temperature differential temperature gradient. Based on this data, this IRC differential temperature gradient was designed. This is a significant contribution that. And this is one, you can say, rehabilitation scheme. You can say balance cantilever, how the external pre-stressing was done and what was the response. To this response, the external pre-stressing was controlled. This is another view of the instrumentation of the.
So sorry to
you can say,
interrupt,
well,
Mr. Garver. I would like to request you to please conclude in a minute, please.
yeah. So this is the earth pressure, sir. This is the inclinometer position. These are the various threshold, and this is the, you can say, model updating technique combined with the field data, and you can say the input field data. This is how. This is the sensor, enormous sensor response getting, you can say, processed through a bridge management system. And these are the various parts of the bridge management system. Of course, CRI has developed one bridge management system. These are the various monitoring schedule and GIS environment that is there. And these are the conclusions. And this is the way forward in terms of the latest non-destructive testing as well as the sensor technology is concerned. This is a signature bridge instrumentation, just a few features. This bridge has been instrumented with so many sensors. You see the wind sensors, structural temperature, strain gauges, so on and so forth, as shown in the slide. This is the master computer room where the data is being stored. And this is the, you can say, the dashboard of the, you can say, automatic monitoring response system. And this is the various parameters online, you can say. This is the response.
I'm sorry to interrupt. I have to request you to conclude, sir, please.
This is my last slide. Thank you very much.
Thank you so much. So I'll quickly move on to our last speaker, Mr. Alok Bhaumik, Managing Director of BNS Engineering Consultants Private Limited. and he will be shedding light on bridge failure, root causes, and ways to mitigate the risk of failure. Over to you, Alok ji, requesting you to please open your webcam and share the slides.
Okay. Good afternoon. Is my slide visible?
Yes, sir. Please put it on slideshow mode.
I think I have put it on the slideshow mode. Are you not seeing that in the slideshow mode?
No, we can see the
Oh,
other slides also
okay. Let me
with
try.
notes.
Is it visible now?
Sir, no change.
Oh.
सर आप देखेंगे आपके स्लाइड में सबसे बॉटम में एक स्लाइड शो मोड का आइकन भी है.
हाँ, उसी से कर रहा हूँ.
I think there is some problem, Monica
मैंने
ji.
तो
Let him allow him to continue in the same mode.
ओके ओके
I
बट
think-
सर उसको थोड़ा सा ओपन कर लीजिए बिकॉज स्लाइड्स हाफ दिख रही है ना, तो थोड़ा स्क्रीन ओपन कर लीजिए.
अच्छा, okay. Let me stop sharing and share again.
यस सर प्लीज.
Share window. Is it okay now? Hello?
थोड़ा सा आप यू कैन इंक्रीज द स्लाइड साइज. यू कैन जूम इन लिटिल बिट.
Acha.
You are not able to put it on slideshow mode?
No, I am able to put it, but you are not able to see. That's the problem.
Okay,
I have
so
put it in the
reduce करिए.
slideshow mode. I have put it in the slideshow mode now. Is it visible like that?
I think now it is. Now it
Sir,
is.
it is visible, but again, the slide is not completely coming as in ज़्यादा zoom हो गया, I think.
Oh. अभी
थोड़ा सा और zoom out करिए sir. I think this is fine.
this is okay?
Yes.
Yeah.
Okay. So, good afternoon. I know the time is constrained, so I'll move very quickly. So
Yes, sir.
basically, the topic of my presentation is bridge failures, root causes, and ways to mitigate the risk of failures. The theme of this webinar is safety and sustainability, and we cannot complete this webinar without showing the elephant in the room, which are failures. These failures used to be quite rare in the past, but of late there have been increase in the number of failures, not only in bridges and flyovers, but also in other structures. And these failures are taking place mostly during construction, but there are premature failures as well during the service. And primary reason for this increase in the rate of failure, I would say, this is attributed to the fact that we, the structural engineering fraternity, are not really getting into the root cause of the problem. We are not learning lessons from the failures. And most of these failures are post-failure investigations actually bury them, bury the cause. And therefore, the engineering fraternity is not learning anything. The broad content of my presentation is here, a brief introduction. Maybe I will skip failure case study if the time is short. We will talk about a new newsletter, Crossfall, which talks about failures, and I will conclude. So let me get into the introduction first. The bridges are important. I think Professor Tandon in his opening remarks, and as well as Ms. Monica mentioned how important bridges are. And these structural failures that we witness, they're not just accidents. They are not acts of God. They are results of human error originating from mostly oversight, carelessness, ignorance, bribery, corruption, all these things. And what we perhaps do not realize that much is that when failure happens, it is not just the loss of asset, which is actually a very small component of the total loss. it results in much greater national socio-economic consequences. And above all, it dents the image of our fraternity, the structural engineering fraternity. And therefore, the society looks at us with a lot of question mark in their minds. We all have know in 2013 what happened in Uttarakhand. There are many examples of failures, but I'm just quoting this because the failures during this Uttarakhand flood in 2013 was devastating. More than 100 bridges were actually lost. And when these 100 bridges were lost, actually many of the villages lost their connection with the other side of the world. Many of them would have used those pedestrian bridges for the children to go to school or for the men folk to go to the offices, and the connection is lost. And till now, it is not been restored properly. Even now, the work is going on to restore. Uh, when bridges fail, the community struggle, the development stagnates, and the people suffer. And what you see in this slide is only a sort of a reflection of how people, struggle to cross a stream or a gorge in case there is no bridge. So that's the importance of the bridge. Last 30 days, we have seen collapse of about 4 bridges which are in the news. There may be many hundreds of other failures which are not in the news, are gone unnoticed. But we have witnessed, I mean, it is just to give an example of how frequent these, failures have been. This one, which happened on 29th of March, is in UP, in Bulandshahr, where I think it's a staging collapse which led to during under construction bridge collapse. This happened only on 29th of March. Then we had a failure on 27th of March, just 2 days before, which is again a failure due to during erection in Karnataka, where I think there was some casualty also. We have all seen this the spectacle of this Baltimore bridge collapse in USA. So failures are not just India centric, and this is a disproportionate collapse. Just one particular pier is hit by a barge ship, and that caused the collapse of the entire length of the bridge. About more than a kilometer portion of the bridge just brought down. Then we have seen also one failure on 21st of March in Bihar, where during the launching operation, a particular bridge under construction, it collapsed because of the failure of the launching, some portion of the launching, and there was a casualty also. All these reflects that a lot needs to be done in order to ensure safety and sustainability, which is the theme of this webinar. Why we are not learning lessons? There are many reasons, and I have just put few. The primary reasons I feel is basically a lack of intent by authorities. We are a tolerant society. Whenever there is a failure, unless it comes to the media, the attempt is always to bury it under the carpet. If the media comes in and it is flushed, then the attempt is to find a scapegoat whom we need to sort of put behind the bar or blame. And mostly it is the weakest in the link who is basically being targeted. There is a fear of blame, a ruined reputation. So both contractor, consultant, authorities, they all work together to ensure that this is not published. And there are many other things. I don't want to go through the list. The time is short. What we'll find is in India there is a lack of a proper accreditation of the forensic structural engineering. This part of forensic structural engineering is a subject by itself. And what we do here many a times in the investigation, I find I'm a part of many of the investigations. I have also been a part on the other side of the table where I have been investigated. I have seen both sides. And what I find is that there is a lack of professional approach in forensic structural engineering. And forensic structural engineering is a subject which is not taught in our institutions. And if you want to do a proper investigation, then you need to be you need to know not only the knowledge of subject, but also you have to have an good understanding of the techno-legal system. You have to have good understanding of the contract, and on the top of that, you have to have a proper engineering intuitions so that you can understand the real cause of the failure. That's a very fascinating subject, but it is not being taught. And I think it is time that we have in our institutions forensic structural engineering as a subject, a discipline in civil engineering. Uh, so, very interestingly, it is not only in India, but in many countries, this forensic structural engineering is not taught properly, barring few like USA, where, it is a subject. And very recently, there has been a survey conducted by International Association of Bridge and Structural Engineering. Fabrizio Palmisano and its team, the task group, conducted a survey, and they found out based on this survey as to what is the practice in various 22 countries, including India, was surveyed, and how this needs to be improved. It's a very interesting paper in IABAC, and I would recommend everybody to really go through that. So essentially, forensic structural engineering is basically a fascinating professional practice, and that requires a good technical knowledge, a good record of your experience on the subject, very focused subject, and it's a multidisciplinary thing. So when there is an investigation, you need to also tie up with many other experts, and then come out with the judgment. And you need to have a good passion for the subject. Now, Monica ji, if you permit me, I can go to the failure case study. Otherwise, I can drop it and go to the newsletter. If the time permits, if you give me 5 minutes, I can go through one case study.
So only 5 minutes, please.
Only 5 minutes for the full, then I skip failure case study. Okay?
Yes, sir. Sure.
Okay. So I will skip this case study because that was not the intent of failure case study. I will skip. And I will go straight away to the okay. So now let me talk about a newsletter which has been initiated by Indian Association of Structural Engineers, that is IA Structi, and that is a crossfall. What is crossfall? Crossfall is a confidential reporting of structural failures and lessons learned, and it is a quarterly newsletter published by IA Structi. And for those who may not be aware of IA Structi, though there may be very few, IA Structi is a professional learned society in India with the prime objective of supporting and protecting the profession of structural engineering by upholding the professional standards and acting as a mouthpiece for the structural engineers in India. And what Crossfall does is basically confidential reporting of failures. Anyone can report, give confidential report. He or she doesn't have to name himself. He doesn't have to name the project, not client. You just describe the incident and the cause of failure and what should have been done, what lessons we learned, and we will be publishing that report. It's a free e-newsletter. You can go to the website of IA Structi and download. The benefit of having a confidential reporting is that it provides an opportunity for the engineering fraternity to learn from the experience of others. You don't have to necessarily commit the mistake to learn. And it acts as a tool for bringing in change in the codes and standards, specifications, and practices. It's a source of learning for students, academicians, researchers. There is no blame attributed to anyone because we are not targeting anybody. Therefore, reporter feels free to share the facts. Truth comes out in such reports. It's a very proactive system. It identifies precursors and tries to sort of, prevent by good detailing, by, you learn from others' mistake and improve upon when you are doing the design. It acts in the interest of the public and the society. So far, we started this in 2022 and some 7 issues of Crossfall has been published so far. 24 case studies presented, and these are the 7 issues. So I will conclude by saying that, the whole ethos of engineering should be about delivering solutions which provide benefit to the society. And this can only be done if we structural engineers not only earn public trust, but also retain it by showing that we care. And we must take the responsibility for our work and be accountable. Unfortunately, in India, because of lack of any regulation of our profession of engineering, many of us are actually those who are committing serious blunders which causes failure. They are not they are they go scot free because they are not accountable in the profession. If it is a EPC contract, the contractor is primarily responsible to the client, and the consultant is indirectly responsible. But in many failures, you find that it's not like a medical profession or a chartered accountant profession or a lawyer's profession where there is a regulation, and any error by a doctor, his certificate can be cancelled. But that doesn't happen with the engineers, and that's where is a lack of accountability. So we must create an environment which allows us to consider what could go wrong. Therefore, in case of there is a failure, without apportioning blame to anybody, we must do a sort of a proper analysis, and we derive conclusions as to what lessons we have learned from the failures. And I think the Crossfall provides such a platform where we can do that. Then professional associations like IABAC, IAS, Trucktee should be in the driving seat to improve the situation and to reassure the society at large that infrastructure is safe. And there is definite need to review the existing codes, standards, and practices to minimize the risk of failure. Structural engineers must share their experience about failures they experience. And Crossfall is just one of the medium. There are other means also. With that, I conclude. Over to you, Monica ji. Thank you very much.
Thank you so much, Alok sir, and thank you all the panelists. But before we close, we will do 5 minutes of quick Q&A. Some of the questions we have received in the chat box. So I will try and take up as many as questions I can. And meanwhile, I would like to request all the speakers to only focus on the question and answer the. We can finish the answering very, very quickly. So there is one question. Sir,
2 minutes. Can you give me to finish my presentation? 2 minutes.
सर टाइम काफी ओवर हो गया. इफ यू अलाउ मी, मैं कुछ क्वेश्चन ले लेती हूँ सर. ऑडियंस बहुत देर से वेट कर रही है सर.
Okay.
So there is one question from Professor Raman, NIT Trichy. He is asking, where are we in terms of India of interesting grades of steel for bridges and related applications? And where are we in terms of automated inspections? So whoever like to answer can unmute.
What is the question? Can you please repeat once again?
Okay, I'm repeating the question. Where are we in terms of interesting grades of steel for bridges and related applications? Steel grades, sir. And in terms of automated inspections?
I have to say one thing only. As far as the higher grades of steels are concerned, higher grade of steel is okay for the bridges, maybe road bridges, where the fatigue is not an issue. In railway bridges, when we do the design of the mega bridges particularly, fatigue is a very big issue. And our codes specifies a very well laid down procedure how to do the fatigue analysis after the normal structure design. And that does not helps actually if you go for higher grade of steel, because the design is based on stress range concept, not based on the yield strength or the permissible strength, permissible stresses considerations. So for railway, where the dynamic loads are very prominent, the higher grade of steels are not really very unless until you are using it in compression members particularly, not in tension
and
members.
Automated inspection, anyone like to touch upon? Where are we in terms of automated inspection? Alok ji, you just spoke about if you like to cover up on this.
Yeah, actually, we have a long way to go as far as the automated inspection is concerned. But I think, today in the digital technology, we are in Industrial Revolution 4. And I think this gap is very closing very fast. And let me just inform that now, for this Vidyasagar Setu, which Professor Tandon showed in his one of his slides, which is the first cable bridge in India of 457 meter. Presently, repair is going on, inspection is going on, and they are using a very high-tech automated machines to do the inspection of the stay cables. So I think in coming decade you will see a sea change in the automation.
Okay, I'll take up the next question of Mr. Ankit Gupta. He is asking in composite girder pot PTFE bearing inspection how to do and how to rectify problem of pot PTFE bearings like PTFE material coming out, transactions become excessive failure of bearing. Anyone like to add on?
Actually, in port PTFE bearings, the usually problem comes because of the elastomer squeezing out of the pot. And PTFE is usually provided on for sliding purposes over the top of the pot. So what he says is probably he is confusing the PTFE with the polymer that is filled in the pot. So the problem may be with the sealing ring that is provided in the over the top of the pot. So that has to be inspected, and if there is some problem, usually we go for the bearing which is supplied by the manufacturer, and it is designed also by the manufacturer. So the concerned manufacturer who has designed the bearing, he has to be called, he has to do the rectification.
Okay. There's another question from Amit Gupta. He's asking right material selection for steels and other associated component required as per the application required. Also, there shall be policies for the corrosive area, bridge over sea and river. So, is there any kind of selection criteria for steel when we talk about the bridges? What I'm able to understand, this is his question. Selection criteria. Yes, Mahesh sir. Anyone can talk about the selection criteria of steel.
It's selection criteria, what?
Steel.
Selection criteria of steel for various kind of bridges.
I mean, apart from the normal steel which we have of different strength grades, you have stainless steel, you have also other kind of steel where you have some kind of a coating. It depends on what the exposure conditions are, and the big problem of steel is that it corrodes, and you have to keep depending on what design life you are thinking of, what kind of monitoring you are going to do. Like for example, this that Morbi bridge which I showed. I mean, it just collapsed, and I don't know, 140 people died. It's and it was under repair. It was repaired only for. It was open to traffic after repairs 4 days prior to that. So it's a very serious issue. The corrosion of steel, the fatigue of steel, these are issues which have to be taken into account in all steel bridges if you don't want any accidents.
Right, sir. Right, sir.
Can I come in
Uh,
here, Monica, for
Yes,
just
sir.
to add to what Professor Tandon mentioned? I think since the theme of this webinar is safety and sustainability, the current
Yes.
global trend in terms of selection of material is also the embodied energy or the carbon footprint, and therefore that is something which we have to also we have in IRC we have already started drafting a code on that. So therefore, while selecting now the options with new material or the maybe more expensive material but having a lesser life cycle cost, that also needs to be sort of considered. For example, in many bridges, it is proved that stainless steel as an option may have an initial high cost, but the overall life cycle cost is much reduced because of the uh, the lesser problem of corrosion, things like that, and higher, more longer design life. So all these aspects have to be now considered more sort of seriously than ever before.
Correct, sir. Correct. So I've launched a small poll for our audience regarding the webinar feedback, requesting everyone to please vote on the feedback. How do you like the webinar content, the presenters, and the moderator? And I think with this, so we have to conclude. But before that, I'll just there is a Mr. Purushottam Reddy has written something on railway board advice is to use stainless steel in the railway structures up to 30 kilometer from the coast. Hope it is helping the practice engineers and decision authorities in the department. So this is from Autocompu. He's giving a suggestion. So with this, we will end the webinar. And I'd like to make a small speech. So ladies and gentlemen, as we come to the close of today's webinar on bridge design and construction for safety and sustainability, I would like to express my sincere gratitude to each and every one of you for your active participation and engagement. I could notice that each attendee was very active and they constantly shared their feedback with us on the chat boxes, which we thoroughly, I read each and every chat, whatever you have posted. Our esteemed panelists have shared invaluable insights and expertise on various aspects of bridge design, construction, safety protocols, from understanding the root cause of bridge failure and exploring innovative techniques in structure health and monitoring, and from ensuring safety protocols in bridge to the successful design of railway bridges. We have covered a wide range of topics that are vital to the advancement of bridge engineering. And I also understand this topic is really, really big. 90 minutes is not enough. So we will like to continue with more part of Bridges webinar and maybe some talk shows after this program. I would like to extend a special thanks to our panelists, Professor Mahesh Tandon, Mr. Alok Bhaumik, Mr. S.S. Grawat, Mr. Vivek Gupta, and Shri Ravindra Kumar Goyal for their exceptional contributions and for generous sharing their knowledge with us today. Your expertise have truly enriched our discussion and provided valuable insight for all of us. To the audience, thank you for your active participation, insightful questions, and enthusiastic engagement throughout the webinar. Your presence has made this event a resounding success, and we hope that you have found today's discussion informative and thought-provoking. As we conclude today's webinar, let us carry forward the learning and insights gained here into our respective field and endeavors. Let us continue to strive for safety, sustainability, and innovation in bridge design and construction, working towards a future where our infrastructure is not only resilient and also environmentally conscious and social responsible. On behalf of Metalogic PMS, I would like to once again thanks everyone for joining us today. We look forward to welcoming you to our future webinars as we continue to explore new frontiers in engineering and construction. Until next time, stay safe, stay inspired, keep pushing the boundaries of what is possible. Thank you and have a wonderful day ahead. Have a great lunch.
Thank you, Monica ji.
Thank you. Thank you.
Thank you so much, sir. Thank you so much.